In Hands-on 6, we'll talk about masking sensitive data besides other things. And it is because when using the real portfolio suggestion service, we discovered they use non-sanitized sensitive data in their test environment. So we need to sanitize the data during the learning process, not to be held legally accountable. For that purpose, we'll use SV's data masking feature. In step number 1, we'll first backup our project and undeploy our current virtual service, and that's because for the data masking and stateful simulation hands-ons, we'll create a new project. We'll call it data masking and stateful simulation. So let's undeploy the portfolio suggestion service, but first let's clear the storage because I can see we've logged quite a lot of messages. Press clear. And now let's also turn off the simulation report and the message log, because these should be used only for debugging purposes, for only a necessary period of time. To undeploy the service, we'll press the Undeploy button here. Now the service is offline. That means this virtual endpoint can't be reached at this moment. Also, this virtual service was now removed from the SV database and it only exists on the file system. When you click Open Containing Folder, you will see the project files of this virtual service. These files are all XMLs, so you can version and store them in a version control system like Git. To make a backup of my project, I'll right-click the project root and select Export Project. Optionally, you can specify password and also you can include logged messages. Currently, we don't have any logged messages since I've just cleared them. And the project was exported successfully. By exporting the project, all the project files are zipped to a special vproa file. This is how you can keep a backup of a working solution. vproa files are also handy when you communicate with our support because they can be easily used for issue recreation, and some of our customers also version these files. Okay, let's proceed with creation of the separate project for the data masking and stateful simulation. For the second step inside that new SV project, we'll create a REST virtual service virtualizing the same real service endpoint. We'll try to invoke the new service in standby mode using a couple of requests from the sample XML files. Okay, first let me note down this real service URL, since we'll use the same one. Now in this data masking and stateful simulation project, I will create a new virtual service. Again, I don't have a service description, and the new service will be based on the REST protocol. We'll use the same HTTPS gateway agent, and here we'll specify the REST service. Now we know it since the very beginning. I'll press Next. I'll rename the service to Portfolio Suggestion Service, and let's virtualize it. Now, before we test the service, notice that we have currently 4 virtual services in 3 different projects in our solution. But since we are using the free version of Designer, only 3 of these services can be deployed at the same time. So now when I double-click this portfolio suggestion service, which is currently offline, and when I try to switch to simulation, I get this error since the license limit was exceeded. License limit is 3 services. But even if I go here and for a moment undeploy also, for example, the dashboard service and attempt to switch the original portfolio suggestion service to simulation, it will not be possible. And that's because this endpoint is already occupied by another service. For the original service and the new one, we have the same virtual service endpoint. And that is not possible. You can't deploy 2 virtual services at the same time with the same virtual service URL. You can't even deploy services with URLs such as one of the URLs is a prefix of the other, because in that case, SV wouldn't be able to route requests properly. In some cases, it simply wouldn't know to which of these services to deliver the request. Okay, let's clear these errors here. Let's keep this original service offline. Let's switch the dashboard service to simulation again. And let's test the new empty portfolio suggestion service. Let's call the service with request number 1. And it works. Again, we have some 4 to 8 assets on the output. That looks like we are communicating with the real service. We are in standby. In simulation, this virtual service is completely empty, so we'll get the empty result, along with this warning that the suggest portfolio structure was not found in the schema. So since it was not found in the schema, let's remove this warning and switch the service to learning, and let's learn at least the basic structures. Press send, and now in learning we recorded this message. So when I stop learning now and open the data model, there will be at least one row here in the learned data. We already completed part of this step 3 because we learned the data structures to our data model. And now let's mask out the sensitive data. So when you have a look inside our data model, there is this unique identifier that looks like the social security number. That's definitely sensitive. It shouldn't be here. So this is what we'll mask out. We'll use this regular expression. This is one of the ways how to recognize the social security number. It's 3 digits followed by dash 2 digits dash 4 digits. And we should replace it with the value of SSN removed. Okay, so let me show you how to set up data masking on a column. I'll right-click here, click Mask, and for this unique identifier I have a couple of options. Either I can replace the value with something, or I can replace it with this kind of hash. In our case, we'll use this replace function. And we can either replace the value by some static text, or we can use the regular expression, which we'll do. The value to replace it with is SSN removed. And here is where you can test whether the regular expression works as expected. So for 1, 2, 3, 4 digits, yeah, it works. I'll press OK and again OK. And now let me explain why we had to create a new project for this data masking exercise. It's because setting up data masking will always wipe out all the data from your data model. So you should always set up data masking as the first step when you create a virtual service. And since we didn't want to break our original portfolio suggestion service, we had to create a new one. So this dialog is asking you whether you understand that all the rows in this virtual service will be lost if you specify a data masking on some column. It's very important to understand this and not to make a mistake. So I'll read this carefully and then select this third option. Press finish, and as you can see, the row that we learned is gone, and you can see this special symbol, which means that this column was data masked. And since all our data model rows are gone, let's record new ones by invoking this request one exactly 5 times. And it is important to invoke it exactly 5 times because we'll use the recorded data for the next exercise, for the stateful simulation. After recording, we'll check that all the unique identifiers were replaced with this SSN remove constant. Okay, let's switch to the learning mode and let's invoke our service 1, 2, 3, 4, 5 times. 5 requests, 5 responses is together 10 messages, so we can stop the recording, and in our data model we can verify the unique identifier was indeed removed. And since this was the last step of this exercise, let's check our progress in the dashboard. Oh, we got an error. Yeah, I think I may know why. It's because we are still communicating with the real service. So the dashboard sees the data unmasked, because the data masking only works in simulation. When you contact the real service in standby, you will still see the data unmasked. So let me switch to simulation, and now the dashboard shouldn't complain. Okay. Notice that when data masking is on, you can't switch on message logging. That's because as we want to prevent logging sensitive data. As I already pointed out in one of the previous videos, while working with the real portfolio suggestion service, you can notice it returns a wildly different set of suggested assets for the same request when invoked multiple times. So this is not a very consistent behavior. Imagine that some user presses refresh in the browser to see the current market prices, but what this user actually sees is a completely different set of assets. It's probably due to the incorrectly chosen algorithm on the real service side, but they don't know how to quickly fix it. It will likely cost a lot of time and money, and we can't wait for them. So we will use stateful simulation to amend the service to return only a reasonably different response for the same repeatedly invoked request. We'll keep the same set of assets and change just the market price, but only a little bit. In this exercise, we'll keep working on the same project, and we'll also use the request one to periodically invoke the real and the virtual service. At the end, we'll change the data model so that the response always contains the same set of assets, but each time with a slightly different price in USD. So let's press stop and switch our service to standby, and let's observe the inconsistent behavior. When I press send, you can see it starts with this kind of asset. When I press send again, it starts with a different one. Again, now this one is the same, but this second one is different. So this is the inconsistent behavior we don't like. When I go to our virtual service and press simulate, when I press send, we get one set of assets. When we press send again, we get a different set of assets. Again and again a different set of assets. So according to our current understanding of the data model, that's a little bit strange, because here all the 5 recorded requests were the same. We used request1.xml and invoked it 5 times to create this data model, if you remember. So how comes that each time I invoke the same request, I get a different response? Well, it is because of SV tracks. We can display them here in the stateful layout. The row level detail you can see here in this special column. An SV track is a feature that will enable you to retrieve a different response for the same request when invoked multiple times. So normally the first matching row would win, but if rows with the same request are organized in a track, then first the least recent track position will be retrieved, then the second oldest, and so on till we reach the topmost matching request. You can edit this track by drag and drop or using the drop-down selection here. You can also delete existing tracks here, and once you delete it, then only the first of the same recorded requests will match. So let's keep these same requests in this track that was recorded, and let's only modify the data. And our aim here is to retrieve the same set of assets with just slightly different prices. So let's perhaps use assets retrieved in row number 1 and copy the values to all the other rows. Then the set of assets will be completely identical. So I'll press copy, and here in row number 2 I will use paste response. This will only change my response side. As you can see, these 2 rows are now identical. When I do the same here, paste response, and here paste response, and so on, I have this same set of assets. Now what we will do is we will change the prices, but only a little bit. One of the ways for changing a field for a lot of array items is to display that array in this table. In this hands-on, we want to display the price in USD. So let's hide all the other fields. And just display the price in USD. Now this is the way to edit these 5 array items. Let's always append number 1 to the price. Here we'll append number 2. Here we'll append number 3. Here number 4. And for the first position in our track, we'll append number 5. Okay, when we now restart simulation and start testing, when we press send, you can see our price in USD ends on number 5. When we press send again, the same set of assets got retrieved, but now the prices end with number 4, number 3, and so on. When we reach the end of the track, as we will start cycling from the beginning. So again 5, 4, 3, and so on. So let me now go to the dashboard, and as you can see, after clicking the circle, we got the OK result. The tracks are important if you want to retrieve a different response for the same request. But that's not the only purpose of tracks. In fact, tracks in SV are for keeping context. When multiple requests come from the same user during the learning mode, then if you have this enable learning track checkbox on, SV will record these tracks for each individual session, for each individual user. So in this track, you will not only see the same requests, you will in fact see the whole sequence of requests from that particular user. And it can be a sequence spanning multiple operations that contains multiple different request types. Now, when I select this track and remove it, I will only delete the track and keep the rows and restart simulation. What will happen is when I click send, you can see the same response is getting retrieved, because now always this first row matches. Now the question is how to identify a unique user or a unique session. So for that purpose, go here to the service description section, click edit, and this is where you can specify the session ID. Currently, as you can see for the REST protocol, the client address field is used to uniquely identify a session, meaning requests coming from the same IP address will appear like if they were coming from the same user. So if you have a special header, perhaps, in your REST services with session ID, you can specify it here, and then while recording, you will get much more accurate tracks.